So, well, the topic, what it was sent by Ankita to me, typically in the email, so I thought it the same topic, so it was taking some time to me to find out my slides, like, and when I start putting the slide, it became around 600 slides, then I have to take a couple of hours to reduce them to around, typically around 400 slides. But most of the slides are informative, not really so you know to text with the mathematics too much. Of course, you can probably learn that. So, coming with this, of course, Professor Madhusan already introduced. So, let's come to directly to, I will start a little bit with the electric vehicle and then we will go for, of course, for the charger and then integration of the renewable energy to the charger. So, all three. So, this is typically, if you look into 1996, the GM launched electric vehicle in California, Silicon Valley. And within 2 years, the company became almost bankrupt. I mean, the GM survived because of the outside operation than US. I mean, otherwise it could have been bad. So, the reason being the limit, I mean, capacity of the battery or the range of driving of this four-wheeler. But you know, whatever the technology got developed, it does not go to the waste. And that technology people use for hybrid. I mean, hybrid just after that, 1 or 2 years later itself, people introduced hybrid. And I think around 25 years in North America, the hybrid enjoyed it. I was expecting that it will not come to India. And last year I saw it, even there is a hybrid car in India also. And one of my relative, he has this hybrid car and he says he is able to drive 27 km per liter from this petrol, where the petrol car only you can drive around 8 to 9 km per liter, but hybrid is able to, he is able to drive around 27 km in every liter. So, the energy consumption you can think about, it has gone to 1/3 typically. Of course, there are many technology in hybrid. So, that is going to quite successful. I mean, I saw a lot of cars in Montreal also when I go every year summer with my friend Professor Amrish Chandra. I mean, we have a long journey, probably, I think, how much, like around 48 years together. I mean, starting from
52 years.
More than 50, 50 years, 73, okay, so it's probably 42 years together. I'm like, and IIT Delhi too, and tech together, okay. And then colleague together at Roorkee, I mean, like, okay. So, that I saw there, and after that, typically in 2006, Tesla was introduced by Elon Musk in the same Silicon Valley. And you know now who is Elon Musk and what is Tesla, the richest person of the world, your technology. Think about, I mean, how, so it gives an idea that what is the best time for launching a technology. Are you able to follow? Like, I mean, what I mean, all the technology, most of the technology are available. I will give a couple of more examples also related to electric vehicle. But it's more important the launch of the vehicle. Research always goes much ahead. 20-25 years ahead. Of course, now gap is reducing maybe 5 to 15. When we have a little bit interaction with the industry, so this gap of 25 reduces to 15 years, 10 years, maybe 5 years. I mean, now introducing, the industry is coming closer. R&D also going to be little bit applied to industry and industry also coming towards the academic. So, little gap is reduced, but still the reasonably gap is there. Research have to go much ahead, like I mean, or so. So, that typically then hybrid, plug-in hybrid vehicle. So, all these have been, so this is little bit history to just tell you, like, I mean, now what are the benefits of electric vehicle? I hope most of you might be aware. Yes, what are the benefits like? Of course, this is what Delhi people says, okay. I mean, no emission, no fuel of petroleum kind, and of course, very fast. If Tesla says that, okay, up to 60 miles means 100 kilometers, you can accelerate within 2.5 seconds, like what fast. I do remember around year 2000, when we opened the market, typically to the open market in India, and in Delhi, almost every car was having a dent, because most of the car was having very fast acceleration. So, people are not able to control themselves and they run fast and you get a dent here and there, na? Just put in the back, side, here and there, like, I mean, then of course it changes, and there was a lot of horn, and Supreme Court order came into, I think, 2000, and then after that there is no typically to be horn. I mean, otherwise when I go to North America, like especially Canada, if somebody horn, people see, oh, who's making horn. But in India, it was a very common practice that you have a lot of horn, like also. So very fast, another is cheaper to run. How much cheaper? I don't know whether you have idea how much cheaper it is. I mean, extreme case is 1 to 10th. Okay, this data I just look into. I mean, I think 3 or 4 years back, the ministry purchased around 125 cars for to be used by official like secretaries and joint secretary, additional secretary, and they put in newspaper. I mean, that the fuel used in the car is 80 paisa per kilometer. Where of course everybody will say that petrol, if you have, it takes around 8 rupee per kilometer. So based on that, I just put it that approximately it's 1/10. Of course, it's not necessarily all the 1/10, it may be 1/6, but it's never less than 1/6. I'll just give some of the data. So between 1/6 to 1/10, you are able to reduce the energy consumption. I mean, typically. So if such a low energy consumption, you have 1/6 itself, think about the 50% energy around the world and India too go to transport sector, and that is mainly petroleum. It does not matter whether it is your bus or your car, whatever, whether you have a petrol, diesel or CNG, I mean, it's require huge, and you have to import the oil from Russia, oil to, even you have a very bad relation with the America, I mean with the president also, because you are buying the petroleum from Russia, because even the US want to sell you. So we are taking from Russia, we are taking from US also. And this is causing a very bad relation internationally also. But if we reduce this our energy consumption to 1/6 or so, this is 50% energy requirement. A 50% reduced to 1/5 or 1/6, probably may not need to be fuel to come from abroad here. I mean, it will really reduce the energy consumption substantially, like, I mean, also. So that's about the how cheaper it is supposed to be. And then the cheaper to maintain. Why cheaper to maintain? The example I will give, because Tesla, Elon Musk claimed for Tesla, you not to touch his car for 15 years. If we buy a petrol car, we can retain it for 15 years, otherwise you have to throw. I mean, I was not very keen to, I was running up to last year, Amaze petrol, diesel. So I have to throw after 10 years, I was not willing to, and car was very good condition, like, I mean, like, so in the sense, like, 15 years we have to sell, and when you buy a new car, even of petrol, in very 1 year you have to go 4 times services. That will follow, and every year you have to go for service, other than your accidental or otherwise. But Tesla says 15 years you do not to touch about the battery or anything, you not to touch about the car. So that give a good example that how much is the requirement you are cheaper to maintain. Your number of parts are very less. That will follow. It reduces drastically. People claim this reduces from hundreds to around 20 parts only in the electric car. Like, of course, health benefits, especially for the people like Delhi, it's become very important that the pollution, mainly pollution comes from the car. But of course, it's not only. I mean, people say it is because of diesel and probably the petrol or petroleum. I don't know whether you really heard the news or not. I mean, news came probably from UP. And then in Noida, they are going to ban probably after 1st January, petrol and diesel both. Only CNG and electric will fly. So if Noida will going to do, maybe after 1 or 2 years you will find the same thing in Delhi too. Are able to follow, like, because they have to take very strict, everybody agrees, yes, still they put a lot of restrictions, but still we are not able to reduce the pollution. That's a different issue. Of course, people say some odd even formula which was put few years back, and it probably was reasonable success. But certainly, up to some extent, the gasoline pollution, petrol and diesel have a certainly reasonable stake. We will not say that is totally responsible for pollution, but have a reasonable stake. So that's related to health and of course safety. So electric, of course, vehicle is supposed to be better safety because of lower center gravity. I mean, people talk about, and moreover, you have a better technology also I mean, if you have in Tesla now driverless car, it means it has a better safety. Of course, people say, okay, one car has an accident and all that, but I don't know how many cars you have already have an accident, probably with the petrol car or diesel car, okay. So, one car if it got an accident, you cannot really generalize the things, no. But certainly they say if you have a driverless car, it means it's quite safe, up to so much safe that human intervention is not required, I mean also. Energy security, which I already mentioned it, that you are able to reduce the energy consumption to one-fifth or one-sixth, okay. I mean overall energy consumption reduces, I mean like that's substantial, and of course you can understand the noise reduction. I mean I was just normally go for a morning walk, and you know in the morning 6 o'clock or 7 o'clock there is a lot of hawkers in IIT campus. I mean this what called no? Not only papita food, this Zomato and Swiggy, I mean, the people don't want to prepare the breakfast, okay? They order it. So even in our building, maybe 12 house, but I mean, breakfast is served in the 6 o'clock in the morning in the home. And most of these are using now two-wheelers, electric two-wheelers. So you will not be able to see that there is some noise coming or somebody is coming very close to you, like I mean. So they are, even two-wheelers are also, in spite, I mean, they use the motor which have a little noise, but you can't hear the noise compared to your combustion engine based vehicle, like I mean also. Then eco-friendly materials, people came about you are able to use the material which really have a different kind of, because now you are going to be a latest technology, okay. So you are able to put, and there is a money also, and lot of technology improvement has come compared to the other technology like. Now that is about the some of the benefits, not necessarily all the benefits are covered, but one of the reason for why electric vehicle have to come in 2010, I mean like the oil production and oil demand was at balance, but after that the production start reducing and oil demand start increasing. How to fill this gap? So people find the different means, like I do remember, I mean with Professor Chandra at the, I mean in summer I usually we go for after the lunch we would go on walk, and we were talking, I think, do remember, if I do remember around year 2000, we were just talking, okay, there was a petrol around 40 cents per liter. So we say if it become $1 per liter, probably all car will be, people will not drive or it will be parked in the home. But after around 15 years or later, 2015 or 16, we are going again lunch time for walk, and we found it's already $1.15. And no car was stopped, okay. People have to go ahead, nah? I mean typically. The question is like, people have to afford, but the question is if there is no at all, then you have to find some other means for this transportation system for the fuel. So if fuel production reduces, cost increase is one part, but the problem is in taxes, and government also want to encash about it. I mean you can just see, I don't know how much you feel about what is the cost of the diesel or petrol in India especially. You know 50% is the tax. I mean I was not knowing, one day I just listened to that Pathsala and he says tomorrow car will run with the petrol will be 50 rupee per liter. It was around 90 rupee per liter. So reason he just mentioned that probably more than around 100% is the tax on this petroleum. In speed people have to use it. I mean the taxation government want to encash, I mean, and want to reduce the consumption, but you can't avoid it like. So this certainly this makes sense that you have to look alternate technology, and EV is one of such alternate technology that if you are not going to use the oil like also. Another technology, the electricity, because you can run electric vehicle with electricity, are able to follow like. So if you can run with the electricity, what is the cost of electricity and how it will be the electricity there. So of course we have a limit. You might have seen in even the news in the summer that we have only now coal only for thermal station for 48 hours, 72 hours. This kind of news comes only in summer. Okay, it's not the news any other time. Otherwise they say 10 days, 15 days. I have been in the board of NTPC and they say, oh, we have a 2 month coal already with the most of the thermal plant, like, okay. But the problem is even there have been a coal scam also in India. I mean because some of the coal were imported and there have been from some mines also there have been an issue in the few years back, typically, I mean. But you look into renewable, I do remember around typically in 2010 here, Haryana government launched a scheme to have a solar installation, solar PV installation. and the cost which was given by government is 18 rupee per unit. 18 rupee per unit like. And there was a apprehension by the people, especially the government official of Haryana, that people will generate by diesel and claim for solar. Because diesel generated electricity was 14 rupees that time, and solar is supposed to be 18 rupee per unit. But you can think about it, within the 4 or 5 years, hardly 4 years, it came to 6.5 rupee or 6.47 rupee. And drastic reduction typically of this generation, and within typically you think about around even less than 10 years, 8 years, it became around less than 2 rupee. So how the price is reaching, and when it was the price around 5 years back, you know, this 5 years back electricity was when panel was 30 rupee per watt, 32 rupee per watt, and today panel is supposed to be, even a quality panel is half cost, that is 16 rupee. If you go to Wari panel, that's around 16 rupee per watt or 16,000 rupee per kilowatt. But Chinese have already produces around 9 rupee per watt. The big industry says they already manufacture so much. The grey market, India, the grey market is also substantial. You will find a lot of panels on the side of the road, which are not official. Like they are getting hardly 10 rupee per watt. 10 rupee means 10,000 rupee per kilowatt. So you know, if within 5 years the panel costs have gone to half, or half officially good quality panel which government certified, and grey market have a 1/3, around 10 rupee, from 32 rupee to 10 rupee, then this price we expect it should go further down, and middle is already 1 rupee per unit. So it means there is no reason in next 5 years this also, in India also it should go 1 rupee per unit. So if at the moment you are running a car around 1 rupee per kilometer, maybe after 5 years you may expect in India it may come to 50 paisa per kilometer. You cannot deny the technology. Are you able to follow like humming? So that's and government is also committed in the sense solar. Of course, it was a little slowdown because of several policies. One was the COVID, another was the reason that we are not producing the solar panel. It gets slowed down, but in last 3 years, last 10 years, minister claims that we are able to have a solar generation 3 times. So it's gone already crossed the 100 gigawatt, which is, of course, total renewable they claim around 40%, but the solar itself crosses 100 gigawatt. So even last couple of years it has gone to around 30 gigawatt. So you can see, how the government is pushing. Of course, earlier people have a apprehension to not to install, but government have already declared it. Probably think about I think 1 crores rooftop with a subsidy of 1,08,000 for 3 kilowatt. That's the government is committed. Okay, we will have 1,08,000 for 3 kilowatt panel of 1 crore installation on rooftop. The government is also committed, but of course now lot of private sector also has come into this, and costs have gone to now around 3 crore per megawatt for big installation. If you have a 1 megawatt, then it's around 3 crore is the cost of installation. So day by day, of course wind is also going down, it has also gone to half, but wind, we burnt the wind, in India we burnt the hand with the wind. We started the research first in the wind and then we came to solar. What do you mean by burning the hand? We have a 40 gigawatt around 10 years back, the wind. We are not able to increase much. Now it's around 60, around 8 to 10 years. We are not able to even increase even a single gigawatt of the wind. The reason being what we install this wind in coastal area, that also we are not able to utilize fully because of transmission network and other issues like. But the solar, why interrupted? Because it is everywhere. You can put on your rooftop. And now of course again wind also got a jump, and we have some work with the leading industry, especially Adani. The interesting part is we say solar, if you do MPPT of the solar, it's not required so fast. In general perception is there, solar intensity will not change so fast. So you know to have a MPPT so fast. But when we discuss with the project with Adani, what they say, they have a wind turbine which is 100 meter typically the diameter of the blade, and then there is a solar, because wind, you cannot put completely the wind turbine very, very close because of the wind blow and wind direction and all. So in between they have a solar, and they showed me the video that the blade moves around 60 to 120 RPM only, and the shade of the blade is coming on the panel. I mean, it's not continuously coming, it can be coming slowly, but that's not very slow also. If you are running the 120 RPM or 300 RPM, not 300, even 150 RPM or 100 RPM, that is the wind turbine speed. I mean, like, and with that speed, your shadow is moving over the solar panel. So they need the MPPT so fast that you should be able to track within so much time. And this give a very interesting part for the MPPT for the solar, because in a one string, even rooftop you look into, I was the chairman for both the committee of 1 megawatt, 1 megawatt, earlier director resident 25 kilowatt. What is interesting that they have a string of 11 kilowatt with the 20 panel of 500 watt. It becomes like a 22 panel, so 11 kilowatt is a one string, then 11 kilowatt, and like that they connect with the inverter to connect to the grid, the solar panel. So the problem is, if you have 22 modules in series, there is a chances every module will have, at least out of 22 modules, some modules certainly have some partial shading. I mean, like, but the problem is in series connected modules, if one have a shadow or one have a decreased generation, it reduces the generation for all the modules. Because it's a virtually a current source. I mean, your solar panel is a current source if you connect in series. So if one current voltage does not change too much, but current changes over a power generation, current changes 0 to full. So if current of one module reduces, it reduces the current for all the 22 modules connected in one string. So it reduces, and what they observe it, that there is around 15 to 20% reduction in the power generation. Or other way around, if we take it, if they take some technology in a manner that they use every module separately, then there is an increase in generation around 5 to 15%. Then 15% is reasonably, I mean, increase in generation is substantial. Like, I mean, we say that the solar panel in the laboratory environment give an efficiency of 40%. But when we really make a design of the solar plant, we consider the efficiency about 15 to 20, around 12 to 15%. So where is this 20 to 25% efficiency is going? Nobody analyze it, because that's not in domain of us. We are the only users now. We just as electrical people, we are just user. Maximum we belong to power electronics, so that's we consider only. Our job is not that okay why it is reduced or so. But people talk about material quality and other things and all that. But the true fact is there. I mean, there are many issues related to the utilization of these panels in proper manner. Like, I will talk a little bit about that. Like, so what I mean, there is now more research. It depends on research also on demand. If you have a more demand, then there is a more research into this. Like, so people are start looking where we were losing that energy and how to recover this energy, how to make this better utilization also beyond the cost decrease. Like, so if you are really going to have so much cheap electricity, maybe tomorrow you might have after 4 or 5 years, 1 rupee per unit, the cost of your driving of electric car will be much cheaper. And of course, there is another reason, not only that we are really putting, I mean, I was delivering a lecture in COVID period, somebody asked me to deliver a lecture online, and after finishing lecture, there was a question answer obviously, and I was not knowing the lecture was for electric vehicle to mechanical engineers. All the mechanical people were there. And when they start asking the question, there was apprehension. You know what apprehension? Sir, you have taken whole vehicle to you. Entire car you have taken. Means you electrical people took entire car. What is left with us? I don't know. We have not taken any car part. We have not taken any car part of. Majority is yours. We are only going to replace your engine of 30% efficiency to replace 95% electric motors. Are you able to follow? This reduces the energy consumption to 1/3. And then we have a 40 to 50% regeneration. Are you able to follow? I mean, whatever energy going into kinetic mass moving here, that we are recovering. So that certainly reduces the energy consumption to 1/5 or 1/6. I mean, you have to analyze as an electrical engineer how it is going to take place. So that's the reason. So remaining part is tire is yours, car part is yours, entire technology is yours. We are not into it. Okay, we are only dealing with a kind of electric motor and its control. Nothing else. Like, okay, that's of course we reduce the transmission system and mechanical parts also little bit, but other parts, tire is still there, na? So a lot of parts is still there, and still gear is also there. We can't avoid the gear, like it still remain there. But what I mean, this is the technology, this is another companion technology which you cannot deny. If really you want to go to electric vehicle, still after 20 years or more than 20 years, we still have a line on CNG station. Are you able to follow? And we have not put all the vehicles on CNG. We put only public transport on CNG. Two-wheeler, three-wheeler, taxi and buses. That's the only on CNG. And maybe the car also partly of private, but we still have option of the dual, like it petrol and CNG. So still we are not able to remove the row on CNG stations. We have to get, if we are going to introduce electric vehicle, we have to be careful double. Otherwise, the people have apprehension that how will run the car. The CNG also takes only 4-5 minutes to fill. Petrol takes couple of minutes, CNG takes around 45 minutes. Like if you say electric car will take 1 hour to charge, people will not be happy to. Are you able to follow? So there are many challenges in electric vehicle which really have to think about and related to, of course, the charging itself and how cheap is the charging, the cost is. CNG when it was introduced, probably it was 1 rupee per kg, and now it has become already, I don't know, means like going to be 5 rupee kg or something, even a very high. 4 times price have gone in last 20 years for CNG also. Like I mean, I asked only the drivers which they drive the CNG taxi, like also. So anyhow, this is, so you have to get prepared, and this is the one technology you have to probably enhance this also, otherwise you will not be able to run your electric vehicle. Electricity have to be there. Otherwise it is the things you use the electricity for other 50%. You are using 50% energy goes to the transport system, but there is a 50% more energy goes for other activities, and those other activities are taken care mostly by what? By electricity. Are you able to follow? Those 50% needs, if really you are going to use by the electricity, then what will happen to those necessity? And if part of this you take electricity to electric vehicle, electricity cost also will increase. But in place of that, if you bring a companion technology like this, your generation by renewable, which is everywhere like solar, then probably you will be able to beat the challenge of it. Otherwise, maybe solar also will become electricity. So you have to curb the cost of electricity by putting such another companion technology. And this is nothing but to India, even that the challenge is for the world. I mean, and our challenge is more, the reason being a big population, of course big requirement. Now, I mean the country is also enhancing, so people expect the better service. So you have to certainly provide the technology, and it is your technology, electricity generation, electricity utilization, whether for vehicle or something else like. So coming to, let's say, the classification of chargers, I may little bit 1 or 2 slides may repeat it. Can you think about charging other in electric vehicle? Charging is a more important. You know why it become more important? Car is a one. Also, there may be 4 chargers into one car. The requirement is 4 times. The reason I told you why, because you want to drive the car in the same pace or better pace than petroleum. Are you able to follow? Petrol car or diesel car. So then you have to provide the better facility, and the putting energy into it is through charging. There is no other way to make it into. So if it is one car and 4 chargers is required, you can think about how many chargers you have to manufacture. If you want to introduce 3 crore cars, you might have a 4 times the chargers into it. Like so you might, that's the reason research here, if you go to any leading institute around the world, you will find that a lot of people are working on chargers, and especially on wireless charging. So that's another aspect is coming up. Of course, there are challenges to realize it. So you might have a power here, AC and DC. Both are used. Normally AC we charge it, but fast chargers are with the DC operated like ours. So then your accommodation of charging circuit may be on board on the vehicle itself, or off board like a charging station, or maybe a wireless. All 3 technology are there certainly coming up. And the physical contact, you may be conductive fast charging, or you may be contactless wireless charging, power transfer, both the kind. And of course, direction power flow, unidirectional, bidirectional. Bidirectional also becoming day by day important. You know why? The electric vehicle technology we expect, it's already a lot of research. Our power system friends have done a lot of research. I mean, you know what they say it. If so many vehicles are there, there is a congestion and all that. But it is taken care by energy security other way around. Because when you have a renewable generation, which I mentioned few minutes before, it's an intermittent nature. Are you able to follow? I mean, the wind or solar is not available on the time. Of course, in Delhi you might have a solar, but you may not have wind. And you know, solar is in the daytime, and many times in day also it is not there, in the night it is not there. So certainly to use that effectively, you need the energy storage. Are you able to follow? You need the energy storage means, and simplest energy storage is your battery. So if you have to use a battery, the US people develop a battery in 1986 or 85 or 84. They develop a battery charging battery energy storage system of 10 megawatt 4-hour peaking capacity. Of course, with a lot of power electronics. That time, the large rating devices were the GTO in 1984 or 85. 10 megawatt battery energy storage system with 4-hour peaking capacity. Means 40 megawatt hours capacity of that. And you know that installation, of course, I have to go through it, the complete, it's a Walker paper is industry application annual meeting, and later on it was published in Transaction in 1986. I mean, like for this, and I have to go from power electronics aspect into it. Okay, what are the power electronics used into it? And they were using like a typically 18 pulse converter, voltage source converter of 18 pulse. They could have operated in PWM, they operated in PWM, but that was increasing the losses around 2% more. So they go into fundamental frequency switching of 18 pulse by improving the power quality on the grid side. With the 4-quadrant operation of this battery energy storage system, your reactive power control and active power control, like. But you know, they didn't build up another one of that large capacity. Chinese, I think around a decade before, they have gone around about 9 megawatt battery energy capacity, again 36 megawatt hour, like. But they also didn't build up another one. You know, if you have a 10 megawatt battery energy storage system, you know how much area you will require. I mean, like, you require big space, there will be a big cost, and you require separate substation for charging a 10 megawatt battery. 10 megawatt battery means you have to charge with the 10 megawatt and you have to discharge also with the 10 megawatt. You require separate substation. So it will impact on the grid also. And apart from lot of space and then replacement, batteries, they have a very low life. I mean, they couldn't. But if you look into electric vehicle, the cars, it's a good battery energy storage system. Because your car will be lying into entire distribution system. No? I mean, like, only what you have to make it, if you have a bidirectional charger, you can say, okay, in the night electricity is cheap. You charge your car batteries. Like a Tesla, I have 100 units into it, 100 kilowatt hours into it. You may not use 100, like in the day, I hardly drive 50 to 60 kilometers, which is hardly 5 to 10 units. So remaining 70 to 80 units I can use it. So in the night I can charge the car, and daytime I can sell this if the cost is high. In India we have a socialist country, na? So the cost of electricity within 24 hours is the same, but it's not in the all country or developing country. Of course, in India also the transmission company and generation company have a varying cost. I was interacting BSS as well as NDPL both, and they mention, yes, we are giving to like your IIT around 10 rupee 25 paisa per unit, but we are getting in summer 9 rupee 50 paisa, and winter we are getting 2 rupee 50 paisa from transmission company. So cost here also, but it's not known to public. I mean, and time will not be very far like petrol and diesel, na? It's an open market. You may say it's automatically changes. Many countries electricity prices also automatically changes. So time is not far that you will be keeping the cost, and it's very easy to really monitor. I don't know, many of you might be knowing from power system in year earlier. I mean, I'm talking about even up to 90, the frequency variation on Indian grid was like a 48 hertz to 52 hertz. And many equipment we use, certainly the imported equipment. One of my friend who was in NREB and later on the POSOCO, he was normally on the shift, and he says today frequency have gone 48 hertz, 52 hertz. Dr. Lakshman Hari used to mention and phone me. Typically, he retired from Power Grid finally. You know, only a Indian government put regulatory commission. And what they did? You connect the price with the frequency. Because frequency is a good measure on AC grid. If frequency increases, means you have a surplus generation, surplus electricity on the network. So it is the price. If frequency goes down, it means a deficit of energy on the electricity grid. You increase the price. It's so simple. And now you will see your grid have not a frequency variation more than 0.1 hertz. I mean, the new generation may not be knowing even this phenomena. Now the frequency variation on your grid is not more than 0.1 hertz. In our time, we have seen 2 hertz variation. Standard was 3% means 1.5 hertz, but while violating that standard also it was going plus minus 2 hertz. But now it is 0.1 hertz because it is related regulatory commission just put the price related to frequency. So same concept you can put of course to grid in a manner that you can make the cheaper the price if frequency going up. Okay, you can charge your car, and when frequency goes down, you can sell off your car electricity, maybe in Tesla car 50 to 60 units with no time, and you can earn the revenue and you can run the car free of cost. The benefit to utility will be you are running a free of cost. You will be, they need not to install the energy storage. So you will be automatically, apart from that, the AC grid needs lot of reactive power requirement. You might have seen the capacitor panel on substation, and that's give a reactive power only of one category, leading reactive power. Sometime in the night voltage goes up, you need the lagging reactive power also to trap the voltage. They don't have means of that. Of course, in Indian grid we have, if you look into the Panki power substation, they have a 9 MVAr 4 reactor, even for lagging reactive power, but controlling the transmission voltage, not the distribution one. But the question is here, if you have a bidirectional charger with voltage source converter, of course, Professor Amrish Chandra could have covered in the power quality aspect this, so you can have a leading reactive power as well as lagging reactive power. So you can sell of reactive power also if you are not selling active power from your car. In your car charger, if you have a 11 kilowatt charger, okay, on board 11 kilowatt charger, then you can give 11 kVA kVAr reactive power also to the grid and sell the reactive power. So you earn the revenue with your car, because this car is supposed to be connected already all the time with the network. So that's what I mean why you need the bidirectional chargers. So you make the grid smarter. Are you able to follow? Because you are able to give a distributed reactive power to the grid and you are able to give a distributed active power also to the grid if required. But both will be required, of course, and you have a converter which can operate in 4-quadrant operation of active and reactive power, typically So that's the bidirectional converter. I can give you another example. I asked one of my startup to have bidirectional charger into e-rickshaw itself. You know why? I have gone to my village in UP, and there are 8 or 10 people who drive the e-rickshaw. And our Chief Minister of UP give electricity, he claimed, we give electricity for 18 hours, but not for 6 hours. And 6 hours electricity not in the village at what time? Morning 6 to 10, evening 6 o'clock to night 10 o'clock. Because they have to give the electricity to city. Because that's the most of the activities in the city take place. Market is open, everything is open in the city. So if they have a shortage, they cut only electricity from the village and maybe in the morning also in the same way. So I look into this e-rickshaw person, when he bringing a e-rickshaw into the home, certainly might have a half unit or quarter unit electricity into a battery of e-rickshaw. So if you put a kind of same domestic inverter feature which is bidirectional and you hook up into the home socket, you at least run a couple of fans and around 4 lights, your children can be study, and you can have a meal also in the light and evening activities without any problem. And whenever 10 o'clock electricity comes, up to morning e-rickshaw is fully charged. And technology does not mean the cost. So what I mean, you just put the domestic inverter feature into the e-rickshaw charger. I asked one of the person, interesting story also comes not and here. I asked one of the startup, okay, do this. You know what? The e-rickshaw chargers which comes from China majorly, We work, I will show some slide, we work on that, okay. It's designed with the isolation for 50 kilohertz to 60 kilohertz flyback converter. You know what this guy domestic inverter people were putting? They were putting 50 hertz transformer. So when we work out, okay, 600 watt charger or 500 watt charger, ask the transformer, that somebody transformer, the guy asked the transformer, of course the domestic inverter person making is still the inverter with the 50 hertz transformer. The cost gone around 3,000 rupees or 4,000 rupees of half kVA transformer. So charger start coming like a 6,000, 7,000 rupees. I told, of course China is giving 4,000 rupees, like they say it's going to 6,000, 7,000. I told why it is going. Then like transformer is a very costly transformer itself is more than 4,000, 3,000 something. Around 4,000, 3,000. Why transformer is 3,000? Like I couldn't follow 4,000 like of 500 kVA transformer 600 VA. Then I found it. I asked the person who gave me the address, I told here this. So then he clarified, sir, it's a 50 hertz transformer, not the 50 kilohertz transformer. So if you have a 50 kilohertz transformer, certainly it will be costing around 250 rupee. Okay. Because same SMPS, na, you just see linear power supply in your lab which is 5,000 rupees. Okay, and switch mode power supply of the same rating of your computer. Linear power supply of the lab you might have seen, na, 60 watt, 2 ampere and 30 volt. It comes around 5 to 10,000 rupees. Na? But if you have some computer's power supply of 350 watt, it's hardly 250 rupees. Okay, that's mainly the size reduction, cost reduction of your high frequency transformer. The question is, you have to adopt the technology, but the right technology, not the domestic inverter 30-year-old technology. Okay, then the price will come in the same like. So what I mean, that gives the, and if you really go to another, I was just talking, if you put lithium ion battery and you have a bidirectional, you have a lithium ion battery supposed to be charged at least from 2.5 kVA or 3 kVA charger. You have a 3 kVA DC set. If you have a e-rickshaw with a lithium ion battery which takes around 5 units, you have a 3 kVA DC set. I mean, it is good for function, good for birthday, good for marriage party in the village. Are you able to follow like? So it serves the many purpose you can think about like, I mean. So that's, I am talking about lower rating. Higher rating, I told it make the grid smarter by having a 4 coordinate operation of your voltage source converter in this bidirectional charger like also. Well, that is about the, now this is you think about why one car will have a 4 charger. You have a fast charger on the highway, are you able to follow? You will require fast charger on the highway. You will have a typically single phase charger wherever single phase is there, small rating, maybe like a typically a 10 ampere or 15 ampere charger, not more than 16 ampere, you are not allowed single phase. Nah. So it may be 15 ampere, but you have if you have a 3 phase, you can have even a 11 kilowatt on board charger. Apart from that, apart from these 3 chargers, I will tell you maybe after 5 years or so, you may not have a patience. You bought a Tesla car of let's say 36 lakh which is announced in India, or otherwise you take a Tesla car of US which is costing around 1 crore, will you have a, I mean, will you like to put the socket into for the charging and when you go into home? Certainly you will like to park your car and automatically it will charge. I mean, if you are really spending so much money, you don't expect to go to the petrol pump, somebody put the hook. If you really put on platform, either in your office parking or in the home, you should be able to put on a place where you park your car and wireless charging will charge your car with no contact. So that technology have to come. If you are paying a good cost, the wireless charger is also there. Why I am saying that it will be really in maybe 5 to 6 years positively in most of the car. The reason every IIT, NIT, you will find couple of faculty, even 4 or 5 faculty member is working on wireless charging. Where that research will go? Are you able to follow? That research is only for that wireless charging, how to go every vehicle. It's not really 4-wheeler, even people start working for 3-wheeler, 2-wheeler, as well as even for bus.